5, 4, 3, 2, 1. Liftoff. And the Titan IV with its Mars spacecraft has cleared the tower.
In the late 1990s, NASA is planning to conduct an unmanned mission to Mars. Its purpose is to collect soil samples for return to Earth and to perform other scientific experiments. This video depicts one possible scenario for the 3-year mission. 2 payloads are launched aboard 2 Titan IV rockets. Upon arrival at Mars, an aero capture maneuver is used to place each payload into an elliptical orbit. One payload contains a Mars Rover and a Mars orbiter with an Earth return vehicle. The other payload contains a Mars Ascent vehicle and an imaging and communications orbiter. Shortly after a circularization burn, the Ascent vehicle separates from the imaging and communications orbiter, performs an entry maneuver, and descends to the Martian surface. Similar to the Ascent vehicle, the Mars Rover lands. Equipped with artificial intelligence and a stereo video camera, it spends a year exploring the Martian surface. During this time, it transmits digital video images back to Earth and collects soil samples. When sampling operations are complete, the rover is instructed to rendezvous with the Ascent vehicle. Once there, the sample canister is transferred. The Ascent vehicle then rotates to the vertical launch position, and the rover departs to conduct further scientific studies. Ignition occurs, and the boost module separates from its launch platform. After an attitude maneuver, the vehicle is placed in the same orbit as the Mars orbiter. A radar scan is performed to locate the Ascent vehicle. Upon acquisition of signals, the orbiter performs a series of maneuvers to rendezvous and dock. A docking complete signal initiates transfer of the sample canister to the Earth return vehicle. The Ascent vehicle then undocks to allow separation of the Earth return vehicle from the orbiter. The return vehicle performs an injection maneuver to initiate trans-Earth cruise. When thrust terminates, the engines are jettisoned and solar arrays are deployed for the 1-year trip back to Earth. Upon arrival at Earth, the return vehicle deploys the Earth Aero Capture capsule. During aero capture, friction from the Earth's atmosphere slows the capsule. After aero capture, the aero shell is detached and a burn is performed to place the vehicle in the space station's orbit. The return vehicle is retrieved by a space station-based orbital maneuvering vehicle. The sample canister is quarantined at the station until it is retrieved by a space shuttle for return to Earth.